Okay, so then the next part of that assignment was kind of like thinking about this next little GC file that you have to do. And this will be for Tuesday. This is a pretty short assignment. Once you figure it out, it's pretty short and easy. But just let me implore you that this is about, the name of this GC file is generalized parametric. Generalized parametric, using parametric functions, what we're learning in class now to do this. There was a semester where more than half the class turned in a file called generalized parametric, and their solution to this had nothing to do with parametric functions. It was just graph the function from lower bound to upper bound. Okay, well, we want to use parametric function to do this, and in this next part of the assignment, the bottom of page 2, is got you thinking about this. So what I have here is two functions. I'm graphing two functions with each one with two sliders. So for function f, I've got the left and the right of f, LF and RF. And then for g, I got the left of g and the right of g, LG and RG. And so all I have to do is put the function in. So here I've put in this sine function. And then I can just move the slider. And it will, so right now I'm starting at negative 3.1. So this is the starting value of x. And then I want to end at, I want the right bound to be negative 1.9. So this is showing function f from negative 3.1 to negative 1.9. So we all know that you can do this very easily. You can just say y equals f of x, comma, LF is less than x is less than RF, right? That's not what I'm asking you to do, right? So that would be a perfectly legitimate solution, but I want you, this is a practice for this stuff that you were asked about in this assignment, about using parametric functions to do this. All right, and so then you can come in, and so here's the g function. So I want to show g from 1 to 5. So right here I am showing g from 1 to 5. But then I can come in and say, oh, this is the wrong function. I want to do what? 1/2 ln x plus 5 times cosine x. No, I want 3 times ln. There we go. So now I just changed g, and it changed accordingly. So now I'm showing for the blue function g, I'm showing its function, and I can again change the bounds. So you basically have two more command lines. You're going to have one command line to graph function f as a parametric function, and one more command line to graph function g as a parametric function, so that when you change these endpoints of the intervals, it graphs exactly what you want. Is the task clear? I think after thinking through this assignment, this is going to be, should be fast. Okay, so that'll be due Tuesday. Yeah, well, the user can come and change the function.
Oh, okay.
Yeah, the user can come into your file, put any function they want in there, and then change the endpoints, and it will graph that function with those endpoints. Yeah.
So we have to make it where, like, if you alter the g of x function or the f of x function, the whole equation.
Yeah, it will graph whatever you put in for g. Yeah, it'll graph whatever you put in for f from LF to RF, and whatever you put in for g from LG to RG without changing anything else in the file.
Alright.
Yeah. Sure.
You want us to use sliders too, like you did?
The beginning of your file should be just like this.
Okay.
Yep, and then you got two more command lines. One is command line for graphing f, and one command line is for graphing g, but you're doing them as parametric functions. Yes? Okay. All right, how'd the last page go? Is that fun? Is that cool? No? And then you read it several times over and over again, and it started to make sense?
Sitting there staring at. Yeah. It's supposed to be a cat breed or something.
Okay, so before we talk about this, are we ready to hand in the written homework? Can you make sure you put your name on it? Yeah.
Like I can literally just copy and paste it right now into an email and send it to you, but I wrote it right on my computer.
Yeah, just email it to me.
Some of them were like our answers on GC. Should we email you or?
What's that?
Some of the questions like required us to use GC.
Yeah, so I think I just said write out your command lines. Did you write all your command lines out? I think that's what it said. Come on. Wow. Okay. Okay, so control 3 equals cosine 2 pi t sine. So what do I want to do? I want to show more of z, right? Oh. So how do you get that much if t is equal from 0 to 1? What am I missing here? So it says t from 0 to 1, but how do they show all that when t goes from 0 to 1? Oh, okay, I see. That's in part 2. It's not right at the beginning. Okay, so that's what you got when you first put it in? And now we want to make the spiral k times this dense, right? So this is not dense, right? It's like stretched. So we want to make it k times this. All right, everyone turn in their written homework? Hold on. Yeah, stack it up in the middle. So how do we make it k times this dense? What does that matter of? Is that a matter of x, y, z, or a combination thereof? Okay, she wants the input to be 12, but we want it k times this dense. Yeah, control 3 gives you the three matrix.
Ah.
So we want it k times its dense. Does that have to do with x, y, or z? Z? Yes?
I do it 2 pi t times k.
All right, so you did 2 pi t times k. Let's try that first. What does that do multiplying by k like that? So then I can come over here and say, k equals 10. Did it work? The k times its dense? Looks like it. There's 4, 20. T. Yeah, so when you're looking at those very, very closely spaced curves, but then 2 layers of it, you get these cool waveforms, right? Okay, so it looks like that works. So did someone get it to work by just changing the z coordinate? Someone said it just had to do with z. I don't know that. So like someone suggested z like this. What will that do? What's that? Like k times less dense? Like
Yeah.
That's what I said.
That's cool
I mean, it's true, right? Changes the
so how could I enter k so that it actually is denser then? What should I put in for k now so that it's actually denser?
so real small.
Like what?
Or 3.
No.
So what happens? So we're still getting one rotation because t goes from 0 to 1, so we always get one rotation, but now it's just how much does t change for that one rotation? So this doesn't work, right? This doesn't work. We need the k to be like Kyle said with the cosine and the sine. Okay, what about the next part? Was that the cone? All right, so what does that have to do with it? We need what the circle to like as z increases, we need the circle to grow linearly. That makes a conical shape. So how are we going to do that? Okay.
Didn't quite get that far, but I thought it would be modifying x.
You modify both x and y.
How do you modify it?
Multiply both by t.
Y multiplied by t.
Then you multiply by t. That means that the radius of each subsequent circle will get larger and larger and larger.
As t increases, right?
As t
So
increases the
as t goes from 0 to 1, we're going like k goes from 0 to 2, right? So as t goes from 0 to 1, we're getting z from 0 to 2. So then as t goes from 0 to 1, our radius is going to just grow as z grows, right? Okay, now we want this thing to flatten, right? So we're going to bring what? N into it, have an animation where it flattens. How are we going to do that?
Replace 2 with n.
For-
In the z.
In the z? So then when n is 0, what do we get? everything, yeah, everything will be in the xy plane. And then when n is, say, 2, so you want to vary n from 0 to 2? Maybe 0 to 3? There you go. If you hit option, so it used to be the other way, but now if you hit option when you push play, then it'll go back and forth. So it'll give the n and then it'll decrease n. Okay, so it's cool, but do we understand the mathematics?
So if you were to just modify one, the x or the y,
Okay.
that would make it like elliptical, right?
Well, elliptical, so let's think about that. So how would we make this thing elliptical? Are you saying take one of the t's away?
No. Like there would be like different values of t.
Okay.
So I don't know, we could do cosine is t, and then we could do sine is 2t.
Right. That's going to give you an elliptical. So if we're looking down on the z-axis, yeah, there we go. So let's try to predict. If I just took one of the t's, so instead of changing one of those t's to 2t, what if I just take t away from one of them? Without doing it, can you predict what's going to be like?
The radius like along the y be just 1 all
Okay.
the time,
Mm-hmm.
no matter what t is, and then for the x radius would just increase from 0 to
Okay.
1.
And so then what will that look like?
So it's like
It would be like
That's crazy, right? What will that look like?
growing just this way, and then being the same this way.
Yeah, okay. I still can't imagine it though. Can you imagine it? Because all I can think of is an ellipse, right? But how is it? So the ellipse gets bigger also. So this would. So it's kind of more rectangular, but still circular.
It would still be an ellipse. It would just be like only one radius would be growing, right?
Okay.
just
Yeah.
like
Yeah. Right. Still an ellipse, but only one radius grows.
Whoa.
Oh, okay.
That's not what I thought was going to happen.
I said. So it starts off like an edge, right? And then the more it goes up, the more it becomes circular, right? Like right? So it's an edge, and then it's like the x catches up to the y. So there's one cross section. Oh, jeez, there's one cross section where it's circular.
that's at t equals 1.
Right. So z. So that would be at when. So then, what would happen if we looked at more of it? So say we went to. What would happen after that? So it's going to like look the other way, right? And then I want to show more of z. Not seeing x. So x should keep growing, right? Oh, it's only from only from 0 to 1. So in order to see it, we'd have to make t go from 0 to something else, like from 0 to 5. Let's try that. No. Let's try 2.
Oh, so it was always a circle because t went to 1.
Right, because it ended up at a circle. But if you let t grow bigger, so it starts out like a line that way, and then at what, t equals 1, it's a perfect circle, but then it starts elongating the other way, right? What's going on? Why don't it turn for me? I don't know what I'm doing. Okay, anyway. All right, let's do something else. Okay, any questions on the parametric assignment? And then you have this short GC file. The other thing you have for Tuesday is we have the class project. We have to get going on that. So we're going to have you think about a idea for what your content will be for your class project. So let's look at that. So this is last year, but so course project. In the modules area, I'll start a new module called course project. And so then this is the assignment, and this is also for Tuesday. Okay, so build from the readings in this course to propose an idea that is important for high school algebra or pre-calculus students to understand. Topics in pure geometry, especially the Pythagorean theorem, are not allowed. So one year we had like 5 groups doing the Pythagorean theorem. Okay, so we want something that's going to lend itself. The GC is going to lend itself really nice to something functions based, right? Functions based. Okay. So pre-calculus is probably the arena we want to stick to. So something in pre-calculus, or calculus if you want to go for calculus, that's fine too. So we want to explain the understanding that students should have, and make an outline of a sequence of tasks that will support students developing that understanding. And then you think of these as discussion points that you will incorporate into your lessons. Okay, so your idea and topic should be in the realm of variable, covariation, and or function. So something in pre-calculus or calculus. So when you think about what you want to teach for Tuesday, when you write this up, you want to have something substantive about exactly how you want students to understand what you're going to teach. So maybe if you guys have been exposed to pathways, so something in the realm of pathways pre-calculus is really good, because in that curriculum it's already it's built into it that they have these meanings and understandings that they want students to have. So in your proposal, you're articulating that. So I want to do exponential functions. And this is what I want students to understand about exponential functions, right? I want them to understand that it's based on blah, blah, blah. And yeah, so what's the underlying meanings and things that you want students to understand about whatever topic you pick, and not just, okay, these are the formulas that I want them to know and how to use the formulas, right? So just think about what I'm modeling in this course. That's the way you want to think about developing this component. That I have things in my mind that I want you to get, and I think about a conversation or a topic or a conversation or a discussion that we're going to have. I'm building GC files to support that discussion, and it's very different than formulas, examples, how you do it, right? Okay, so this is for Tuesday. So I want you all to think about that, and things from pre-calculus, things from pathways would all be really good things. So something function, covariation, variable. So the GC is going to be your main tool for building didactic objects and using those in your lesson. So this is just brainstorming and articulating an idea, all right? So this is just the first step in the whole project. Is the task clear? Yes, please.
So we just have to like answer the questions. It doesn't have to be like an actual proposal. Like
It's proposing an idea. Yeah. So it's proposing the idea that you want to do.
so, but we just have to answer the questions. We don't have to write it out like a paper or anything, right? Like an actual proposal.
No, it is a paper. You're writing out a paper, and you're addressing these three things.
Okay.
Okay. But so yeah. So this is going to maybe. It's not going to be half a page. Okay. Like it's not going to be like one sentence, a phrase and then a sentence and then two sentences. But it's not going to be a 5-page paper either, okay? So something substantive where you're going into detail about this idea about the math that you want to teach, whether it's exponential functions or something with trig, quadratic functions, polynomials, just constant rate of change if you want to just do constant rate of change, or linear function, so any of that stuff would be good. But in this proposal, you're going into a little bit of detail about how is it that you want students to understand this topic that you picked. So be detailed and specific. Is the task clear? So those are your two things for next Tuesday. The very short GC parametric file, and then this. So this will take more. This should take more time. You're reflecting, you're thinking, and you're trying to articulate what it is you want your students to understand about the topic that you pick.
Number 3, does that sort of relates more to how exactly we use GC? So should we like how detailed should that be? I guess because we're starting with an idea, so it might not.
So it's going to be like your module is going to be like a 3-day teaching module. So you're thinking about 3 different like 3 classes, and you're trying to maybe start thinking about like what will be a general outline for what you'll do in class 1, class 2, and class 3 in terms of a sequence of tasks, right? So you might talk about some particular didactic objects, some discussion, some worksheets, but in sequence, right? So you're just kind of starting to think through the sequence that you would present these things in order for the students to achieve the understanding that you're going for in number 2. Does that answer it? So I would say somewhere, this is ish. It wouldn't be a half a page, and it wouldn't, even wouldn't be like 4 pages, right? So somewhere to do this assignment effectively would be a half to 4 pages, I would say. And I could narrow that down more, but I don't want to, limit you, right? So, or make you think that it has to be exactly this many words or this many pages, right? But it should be substantive, but it shouldn't be a long paper. That's all I'm saying. Any other questions about that? So I will put those details on Canvas. And then I actually on Canvas I've put up like kind of the next 2 weeks worth of assignments. So if you go to upcoming assignments here, so here's for Tuesday. Project proposal, GC generalized parametric. Next, a week from today is going to be the next critical précis. I will post that article. The following Tuesday, you'll have what's called a lesson logic reflection. This is the second assignment as part of the project. So as part of all the files in your project, you're going to be developing what's called a lesson logic, which is like a lesson plan, but then gets into more of your rationale behind your choices rather than just what you're doing. So lesson logic reflection is what's the logic of the lesson that you're planning. So it goes into rationale. So before we start working on the project, there's this assignment, this lesson logic reflection, so you can get a really good idea of what that is. So you can do a good job when you come to writing yours. Okay, so I'm going to provide you with one, and you're going to kind of dig into it and dissect it and answer some questions about that. And that will help you know exactly what I'm expecting in your project when it comes for you to write the lesson logic. Okay, so that's the following Tuesday. And then the Thursday the 8th is the next major assignment, major GC assignment, which is the GC marble drop. So let's do that. So all this is so that you can, if you want to start working ahead, especially like the marble drop, you don't want to start on Tuesday, November 6th on that. You want like a week and a half to get going on that, so you can ask me questions and work it out. This is more like sand unloading in terms of a major assignment. So let's take a look at that. Yeah.
For the final project,
Yeah.
is that going to be like on the final day of class or like
Yeah, we'll do the presentations. Let's see. So there's just 8 of us. Yeah, so we could do the presentations like either we're supposed to meet. We're like technically we have to meet for the final exam, so maybe we'll just do it during the final exam time.
Okay.
So then we'll have plenty of time to do 4 projects during that. So that yes, the presentations will be due the day of the final exam, and then we'll do the presentations during the final exam. Okay, so here's the marble drop. This is a cool file. Can you read that, or do I need to make it bigger? Let's do this. Is that better? Okay, so. Oh, I can't do that. Sorry. I need this. I can make that bigger. So I made that part bigger. This is still pretty small. I can read this to you. It says, the fictitious marble gets a running start. So let's just do that. And you know, it's here. All right, so the fictitious marble gets a running start and falls at a constant speed. The real marble falls as gravity and starts the exact moment that the fictitious marble passes it. give the fictitious marble a speed so that it and the real marble tie, hitting the ground. When successful, change the height and try again. So I'm showing an initial height, so you can change the height. So I'm showing initial height, say, of 1705. And I set my fictitious marble speed at 100. And if I hit go, so as soon as the fictitious marble passes the real marble, it sets the real marble to fall. So then the real marble hits the ground. You see real marble time is 10.3. Fictitious marble time 17.05. See it again? So fictitious marble starts a little bit higher. It's going to fall with constant speed. That's why it's fictitious. Things don't fall with constant speed, right? What do? They speed up, right? Things speed up when they fall. That's why you don't jump out of a third-story window, but you could jump out of a one-story window, right? Because things speed up when they fall. They don't. So this fictitious marble is falling at a constant speed. So when it gets a head start, when it reaches the height of the real marble, then the real marble starts to fall, and the time of both start. So watch. So here comes the fictitious marble. Now the time starts for both of them. The time is ticking. And when the real marble hits, boom, it tells you how long it took to hit the ground. And the fictitious marble at that speed of 100 took 17.05. All right, so let's play. Tell me what I need to set the fictitious marble speed to so that they hit at the same time. Go. So it's like a game. So I want for this height, 1705. Tell me how I should change FM speed, fictitious marble constant speed, so that they both hit at the exact same time. Go, figure it out. You got it? No? Thinking about it? Got it? You guys get it? You got it now? Oh, you just answer? Yes. Which is yes, yes to what? You got it? Kira, you think you got it? What concept is this testing? What concept is this testing? Okay, yeah, more. But what constant rate of change? So they go the same distance in the same amount of time.
Yes.
What's that called? What is the constant rate to go the same distance at the same time? Average rate of change, right? So this is testing average rate of change. Anyone got it? What do you think, Chelsea?
Well, real marble went 1705.
Okay.
Whatever the unit is in 10.3 seconds.
Feet in seconds is feet in seconds. Okay.
Feet per second, so that's just what the other one would have to go. So I just thought the speed would be 1705 divided by 10.3 to be exact.
That's what you said? what you thought? All right, let's see if she got it. Here we go. Ready? Go. Bam. So then here's the deal. So then we can watch it again. Boom. All right, so then you can change the height and play again. So now let's make the height 1090. So is that same speed going to work? Too fast, right? Too fast. So what should it be this time? So 1090. What was it?
It's like 8 1. Maybe I'm just.
Oh, it doesn't like that. Anyone remember what it was? 6.292? Did that. Apparently not. 8.232. Two, 3, 2. Here it goes. Go. Right, so the constant speed to go the same distance in the same amount of time. All right, this is a challenging project. Notice that n starts at 0, but n is not the time. Look, when does the time start? After n has started, right? So for some positive value of n is when your time starts, right? And then as soon as one hits the ground, it stays on the ground, and the time is the total time to fall is fixed, but n could keep going. See that? So watch. So they both hit. Both are clock stopped. The ball's resting on the ground with the marbles, but n could just keep going. See that? And then there's another option here, another slider that's like real only. So if you just want to drop just the real marble, you could do it that way. So you could just drop the real marble, then fictitious marble time never changes. The fictitious marble starts up above the starting line. And then same thing happens, right? Real marble time. Here, real marble time starts with n. So actually here, real marble time coincides with n. But again, when the marble hits the ground, it stops, the clock stops, but n keeps going. Could keep going. All right, so this is challenging. And so we've got to find the right balance between planning ahead and working on parts at a time. Okay, so if you are working on one part, a little part at a time, you can design yourself into a corner if you're not thinking ahead enough. But at the same time, that is, that there is a benefit to that, right? So like thinking about this in small parts, but you have to have some forethought, or else you're going to be starting over. You're going to have this little part, and this little part, and this little part, and then you're going to realize, well, this is just becoming a mess. It doesn't all work. So it's kind of like the tumor approach. One tumor, another tumor, another tumor, until it's just needs to be removed, right? So yes, you want to think about compartmentalize and take on small tasks, small attainable tasks. At the same time, you need to have forethought about the whole structure of the program as a whole. There's lots to think about here. Anybody have any initial questions?
This seems like way harder than the sand.
Not way harder. No, not way harder. I mean, maybe because we did so much of the sand one in class. Yeah, we developed a lot of it in class, so now you're kind of more doing the development by yourself. But again, please come for help, and definitely collaborate with each other. But just don't share lines. Just don't share command lines with each other, and copy. All right. So yes, work together, share ideas, but then everyone builds their own program. Everyone builds their own file. Did you have a question, Charlie?
Yeah, so when you change the initial height,
Mm-hmm.
that also changes like the initial. Oh, okay.
Yeah, the fictitious marble starts always 200. Looks like 200 feet higher than the real marble. So it's a 200-foot running start.
Okay.
And when we turn these things in, like, do you want like these like written parts like on the side too, or is that just for us?
Less important. This if you have, it's actually very easy to do this. If you have Mac, you can just drag and drop.
Oh, what? Are you kidding me? Oh my god.
But we haven't had an assignment where you've needed that, really.
Well, I mean, yeah,
Is
the
that-
RX, you can put,
So yeah, so up till now, like I've wanted you to put text and things on the graph by using points, right? By graphing points and put it. But for stuff like this, when you're writing, you can just, and then when it just can go away too. So you can start a text line. It's like, I want this to be on my x-axis. And then you can highlight it, and you can just grab. Oh, it's not. Why is it working? It's weird. Sometimes it works for me, and sometimes it doesn't. Maybe it needs to be smaller. I don't know. So maybe it doesn't work with text, but it works with parts of actual GC math lines. You can try. For you, it might work for text, but for sure it's working for me. And then you can just drag and move it wherever you want. Less important, right? Getting this to work is the important thing, right? Getting it to work properly is the most important thing. And then at the end, we want to make it look pretty to help us as a didactic object, as a teaching aid. Okay, so you got two things for